So we spent a lot of time before discussing corresponding angles, alternate interior angles, alternate exterior angles, and consecutive interior angles. And these were angles that were being formed by parallel lines cut by a transversal. This time we're going to switch things around. So the converse, what it does is it switches things around. So for example, we said about corresponding angles that if I have two parallel lines cut by a transversal, then the corresponding angles are congruent. But now we're switching things up a bit. So in these two videos, our lines are not parallel. We don't know that they're parallel. We haven't been told that they're parallel. We can't assume they're parallel. However, we're given relationships about the angles these lines form, and based on those relationships, we can find out if the lines are parallel or not. So the converse of this would be if we flip it around, right? In this case, they're going to tell us if the corresponding angles are congruent, then we can make the claim that the lines are parallel. So the converse switches the if-then around. Again, this was from the last lecture notes. In these lecture notes, it's flipped around. So we don't know the lines are parallel, but we do know things about the angles. So take some time to write these, but not only write them, but think about them. Okay, so again, the emphasis here is that before in the past, right, before, if two lines were parallel, then the alternate interior angles were congruent. This time we're making the claim, okay, we don't know anything about lines. All we know is that there's two lines. And we know there's a line that's cutting them, right? For part B, for example. And all I know is that these two angles are congruent. Okay? We don't know these are parallel lines. We don't know. We do know that angle 1 and 2 are congruent. Well, if angle 1 and angle 2 are congruent, then these lines must be parallel. Now notice, these are the parallel line markings. I can attempt to draw the most parallel lines possible that I can think of, but they're not parallel until I do this. Or in some cases, they have a double one. These are the parallel line markings. I could even be so bold as to say, okay, these lines, I could make them to be parallel. How come? Because if I put these little markings on them, they are now officially parallel. Okay? Now, I'm not going to get into technicalities, but what I'm proposing to you is this. If I have two lines and I put these little markings, then they are parallel. So for part C and part D, again, we're discussing about the opposite, right? So for example, with part D, we're saying that if I have these two angles, angle 1 and angle 2, we don't see the markings on these lines, so we don't know that they're parallel. We don't know, okay? But we do know, for example, for part D, that the consecutive interior angles are supplementary. In other words, what we do know is that angle 1 plus angle 2 is 180 degrees. What this converse theorem is telling us is like, hey, if these are supplementary, then that means the parallel lines are parallel. So again, the big picture here is we are starting off these problems not knowing that the lines are parallel. Our job is to prove that they are parallel because of the angle relationships that they give us. So, problem 2. We have some pictures here, and again, note that none of these have the little arrow markings. That means we're starting off these problems not knowing if they're parallel. We're being asked to prove if these are parallel, and if so, what theorem? Well, we have here, this angle is congruent to this one. That's what these little arcs mean. It means these two angles are congruent. I notice that these two angles are alternate exterior angles. Based on this converse theorem, if the alternate exterior angles are congruent, then what must follow? So by the alternate exterior converse theorem, because the alternate exterior angles are congruent, then the lines must be parallel to each other. So in other words, I can put these symbols on these lines and confidently say that line M is parallel to line N because of the alternate exterior converse theorem. Part B. So we have this angle, and they're not even really congruent. This one is obtuse, this one is acute. These are not corresponding angles. They're not alternate interior angles. They're not alternate exterior angles. They're not consecutive interior angles. So there's no way that we can prove that M is parallel to N. So this is a no. This is definitely a no. A was a yes. B is definitely a no. We don't have enough information to prove that line M is parallel to line N. Part C, we see here they're proclaiming that these two are congruent. They do look both acute, and these are actually corresponding angles. So what do we know about the corresponding angles? If the corresponding angles are congruent, then what follows is that the lines must be parallel. So, based on the corresponding angles converse theorem, because the corresponding angles are congruent, then yes, line M is parallel to line N, and therefore I can actually put my little arrows on here showing that they are parallel indeed to each other. For your summary, what are the 4 ways to prove that two given lines are parallel? Hint, look at those converse theorems.